Hello, this is Professor Rourke Peterson, and what we're going to do today is do an example problem out of Chapter 5, and using this expert system for thermodynamics, also called TEST, which resides at thermofluids.net. The problem we're going to solve is this one here from the textbook, Problem 530. It's a nozzle, and you can go ahead and read the problem there. We have steam entering. We're given some inlet conditions, including temperature, pressure, and velocity. We've got exit conditions, and we also see that there is heat leaving the system, and we're told what the inlet flow area is. We want to find the velocity and the volume flow rate of the steam at the exit. Textbook gives the answers there at 606 and 2.74, so we're going to be able to check our answer. So going to thermofluids.net, we'll click on Test Calcs on the bottom, and this system here will be an open system, and under the generic there we see this will be a single flow as this was steam, so I'll go ahead and select that. And as steam, we'll go ahead and use the phase change model, or PC model. So here on the first state, we'll go ahead and enter our inlet conditions. So we have an inlet pressure of 800, and I'm going to go ahead and click for the temperature as well. That's going to be 400. And we're also told what the velocity is, so I'm going to turn that off and turn it back on so it turns yellow there, and enter 10 meters per second. And we also know the area, so I would click in the area, and we're told that that is 800. I need to change those units to centimeters squared. So that's what's given at the inlet condition, and I'm going to click the calculate button. It's going to calculate all of my other thermodynamic properties of state 1, which is the inlet. So now let's go ahead and specify the outlet. So up here under the state, I'll go ahead and click over to the second state. We're given a couple conditions here, but not quite as many. We're told what the pressure is, so let's enter that at 200, and the temperature at 300. And let's unclick velocity because we would like it to calculate the velocity. We don't want to set that to 0. And the mass flow rate, well, conservation of mass is that this is going to be equal to m dot 1. So now we'll go ahead and grab the number from the previous inlet state. And we'll go ahead and click calculate, and it's able to find several of the properties, but what it has not been able to find yet is the velocity. So we need to go ahead and go to the device panel now and do the energy balance part. So this is device A. It'll be the only device we have. The I state is the inlet state. That would be state 1. And then there's the outlet state. That would be state 2. We're told that Q dot is 25 kilowatts. It's leaving. You look in the diagram, there's an arrow going in, so I put minus 25 to make it 0. This device is producing no work. So I'll enter 0 for W dot, and we can go ahead and calculate those conditions. And now what we'd like to do is to go back to calculate everything in the state panel. So there's where the super calculate button comes in. So I'm going to go ahead and click that, and this is just some information about its solution. But if we come back to our state panel, at state 2, which is the exit, we look right here. We see our velocity at 605.5 meters per second, volume flow rate at 2.74. Going back to the problem, we see that's exactly what the answers were, 606 and 2.74. So that's how easy it is to use the TEST or test system on thermofluids.net.